Okay, hello, Millennium Alliance members and listeners to the podcast. Welcome back to Millennium Live, the podcast where we bring you insights from the brightest minds that are shaping the future of the digital enterprise, that bring technology and innovation to the table. And today we're thrilled to welcome Dr. Bob Lindner. He is the Chief Science and Technology Officer and co-founder at Veda Data Solutions. And as an AI innovator with 8 published patents, Bob is at the forefront of AI and data science and transforming how industries, especially healthcare, are leveraging technology. And in this episode, we're going to be diving into the thrilling advancements and as well as the pressing concerns in AI, explore the differences between supervised and unsupervised learning, and uncover what the business need to know when integrating AI into their operations. So Bob's going to share his favorite AI use cases and demystify commonly misunderstood tech concepts and really give us a glimpse into the trends that are shaping the future of healthcare data at such a critical time in this space. So if you've ever wondered why AI has already become such an essential part of solving today's most complex challenges and how it can revolutionize the healthcare industry, then you're definitely in a good spot and listening to the right podcast. So I want to bring Dr. Bob Lindner on the show. Bob, thank you so much for joining. It's great to have you and to be able to talk to you today.
Yeah, thank you, Connor. Thrilled for the opportunity. This is my favorite topic, so I hope we're gonna have a fantastic chat.
I certainly think so. So welcome again to Millennium Live, and we'll get started. And jumping right in, as I mentioned, you're an AI innovator, a tech guy with 8 published patents, and you've been within this space now for a while, and have seen just the transformation, both long term and short term, within the last couple of years. So specifically when it comes to AI, because that seems to be the topic of the year. What excites you most about AI development?
Yes, fantastic question. I think so in the US, we pay a fair amount per capita for our healthcare, and compared to a variety of other countries, we also don't have the highest life expectancy. But AI, we're sort of really on the forefront of. I really think AI gives us an opportunity in the US to be more efficient at delivering care to people and to really improve the healthcare system. There's a lot of progress being made over the years, and especially in the last few years, in generative AI with lots of interesting applications. And so simply the opportunity to make delivering healthcare easier is what I'm most excited about, related to the topic that we work in at Veda. Just for a little bit of context, before healthcare, I actually started out in astrophysics and studied how galaxies formed. So used AI there also. Its ability to comb through large amounts of data and to answer questions automatically. So it was productive there in helping to analyze data from larger and larger telescopes in order to reduce the manual workload on scientists. And we're finding that it has a similar great traction in healthcare in order to reduce the amount of work that has to be done to deliver quality healthcare to people.
That's really interesting. I mean, I'd not to go off on a tangent, but I think that would be really fascinating to have a podcast about the universe. And there's
Oh yeah.
so much to expand there. So, Bob, you've sparked my interest already. But just to make things, to have that kind of flip side to it, there's because AI it has been around for a while, as you know. And people are only talking about it because Gen AI has really made a difference this year on the
Uh,
enterprise level. So a similar question to that, on the flip side, what concerns you, I guess? What worries you about this technology moving forward, specifically in AI when you have some potential bad actors or what potential possibilities that AI could do to not be such a positive light in business.
yeah, like 100%. So I would think of it this way. It is a powerful tool, right? One of the things that concerns me, I think, the most is you see it once in a while, the diffusion of responsibility and accountability of
Mm.
processes between humans and these new tools. Like, as an example, a number of years ago, there was this interesting story that Facebook was experimenting with AI, and it had like invented a new language to talk with itself, personifying these systems in that story so that it, it went off the rails and learned a new language isn't really a fair assessment at all. It was just kind of broken. And so like at the end of the day, we need to make sure that it's still accountable humans who are responsible for an outcome. What we don't want is we don't want like negative effects to happen with an AI system and then people feel okay to blame the AI. Like, oh, the AI did it. That wasn't me. The AI went rogue and it's the problem. Let's punish the AI. All AI systems are made by people. It takes a lot of hard work to design them, calibrate them, test them, back test them, and get them ready for production usage. It is the human teams that make, deploy, and use AI systems that are in full control of how they work. And that's related to the safety concerns I think that are around for AI aren't so much concerning if we just lean on the legal structures of accountability that we already have and treat these as tools to empower people to do their jobs. You start to get into more dangerous territory when you start to consider if it would replace a person. And I don't think that that's a productive future. Empowering people, look through more data faster, summarize, give it options, test against a lot of scenarios, and then present it to a decision maker. There's a huge opportunity to make humans more empowered, call it like a power multiplier. And I think that's its best use. And we're going to get into a real hard future if the accountability piece ever becomes unclear.
Yeah, I know. And I think we're gonna dive into that a little bit more on this episode. And but I like that perspective of, it's not a replacement, but it's a powerful tool that one could use. Just in terms of ML, and I want to talk a little bit about supervised and unsupervised learning. And I'm still as maybe a couple of our listeners might be still a little unsure of what the main differences between the two are. I know it's really the difference is the type of data that's used. So I would love Bob, if you could kind of dive into this and talk about supervised versus unsupervised learning.
Totally. This is one of my favorite topics. So, we use both at Veda for different purposes. So I'll start with a summary and then I'll go into like an example. In supervised learning, you are asking the system to learn how to answer a question. And you give it examples of questions and you give it examples of answers. And so that it knows exactly what you're looking for. In unsupervised learning, you're asking the system to find patterns in data, but it is unconstrained about how to group the data. So as a simple example, let's say that you're making an image classifier and you've got the goal is it's going to be fed pictures of cats and dogs. And in a supervised learning model, you give it images of cats with the label of cat, and you give it the images of the dogs with the label of the dog. The label is the final answer. It's the ground truth that the machine can trust. And it can take a lot of work to make the labels because you need a trained expert, usually a human, to go through every image and make the labels. You've got these two big data sets. The supervised learning system will look at all of the images that have the label of cat and see what is common about them that makes them look cat-like according to our label. And then it'll look at all the images that have a label of dog and it'll say like, well, what features are different here? It'll learn a way to distinguish them so that it can be fed a new image and it can decide for itself, is it a cat or a dog? So, and this unsupervised learning part, you can use the same data in the sense that you feed it both a bunch of images of cats and dogs, but in unsupervised learning, you don't give it any labels. It is allowed to group the data in ways that it thinks is the most productive. So one algorithm called clustering is a common way. It'll cluster the data into groups that are similar to each other. And what's surprising about unsupervised learning is it may not find the same groups that you think is important. So if we fed this big batch of cats and dogs pictures into an unsupervised learning algorithm, it is possible that it could group them instead into white cats and dogs and orange cats and dogs. It might also group them into animals that have collars and animals that don't have collars. It might come up with multiple categories: animals that are standing on the ground, animals that are sitting, and animals that are on a couch. And it thinks, well, this is the way that I think the data should be separated. It has no notion of what we want it to separate it into. So the reason you might think, well, what good is that, right? It's going to separate them into categories and it's going to surprise me every time. It is useful because it can help people explore their data. You might say, here's a whole bunch of animals. What kinds of different things are in here? And you might be surprised that half of them didn't have collars and half of them did. That exploratory purpose is what unsupervised learning is used a lot for. And it's usually used ahead of designing an actual supervised machine learning system. So when you don't know exactly what you're looking for, and you just need to get some intuition about a large data set, and you want to know what kinds of things are in it. If it's text documents, it might be what kinds of how many different sentiment things are in here. Unsupervised learning can help show you your data in different ways. So what's kind of interesting is you really wouldn't want to use an unsupervised learning system in a repeatable, like reliable production setting, because by its nature, it's going to come up with answers that aren't things that you necessarily know about ahead of time. And so, yeah, let me give you another example about how we use them at Veda. So in helping streamline healthcare data and correct it for the healthcare system, one common thing that's incorrect is the location where providers practice. Where they're listed to be practicing and accepting patients isn't always where they actually are. So one of our main supervised models is a provider at location model, which is asking, hey, does this practitioner see patients at this address? Yes or no? So that's a supervised learning model because we show it lots of examples from the past of when practitioners did and didn't work at these locations in order to teach it the difference. In an unsupervised way, we use that to group specialties together. There's a standard called the NUCC taxonomy code standard, and it is a way to classify all medical providers into a type of specialty. But there's like hundreds of these things. But in our system, it is helpful to boil that down to let's just look at how do providers practice, not necessarily what their full specialty is, but the way that they practice and the way that they behave and move from location to location can help us predict where they're working. And so it'd be surprising, but an anesthesiologist and a radiologist are more similar in their behavioral patterns than they are in their specialty. So those two things might get grouped together in one of these clusters. And so that's an example that, we're using unsupervised learning to kind of simplify the problem space that we're working in. Supervised learning is to answer a specific question.
Yeah, right. So the unsupervised way is kind of having it discover some hidden patterns and kind of look without the guidance of really what to look for in so to speak. So I want to talk. I want to get into AI in healthcare, but before I do, in general terms, probably why people look to you and why you're on this podcast, Bob, is just kind of some key areas of AI and what are some important things for businesses to keep in mind when exploring the use of AI in their business or in their practice?
Fantastic question. Yeah, sure. So they'll do one sort of high level one and one like kind of practical one. At the high level, it's really important to kind of go in to an application where you're planning to use AI and start with a measurement-based culture, right? So I come from science and the scientific method. The scientific method is really critical when applying AI as a tool or any other kind of tool. The reason I bring it up is just because people are so excited about AI that sometimes they can skip steps. Those steps would be, well, if you're planning to enhance or augment a process that you have with AI, it is important to measure how well that process is working now and make sure that the system that you're planning to implement moves the right number in the right direction. AI and automation in general have this interesting cultural impact where it is less likely to be given the benefit of the doubt when it makes a mistake. So if you have a process that is kind of manual and been running for a while, and let's say that it's 90% efficient, typically I'll hear, and you hear this in general, well, that's just how good it is. The people are doing the best that they can, and we're going to live with that 10% error. then what happens is when you plan to improve the efficiency of that process with technology, and if your automatic version is only operating at 90% accuracy, you tend to hear, well, there's 10% error. How do we move forward with this? Like, this isn't good enough. It should be like 100%. And so because it's not a human that's doing it, there's kind of a much higher bar, and that can stop adoption, and it can stop the benefits that you might gain if you use it in the right place. And so making sure to measure before and after what you're planning to work on, to make sure, is AI helping you? Is it a really cool way to do what you used to do, but it actually costs just as much? Sometimes you would miss that if you don't go through like the careful steps of measurement. So, and then, one small practical thing, advice for folks working on AI, is protecting your training data. So and this is true for the macro global scale, and it's also true inside your corporation, which is, as you start to make systems that make predictions in place where you used to have some non-AI based version of that outcome, it is possible to have your training data get polluted with the predictions of AI systems. And so, on the macro scale on the planet, we can see this is probably going to start to happen as the outputs of generative AI systems produce content. That content goes onto the internet. That content on the internet then gets consumed into the training sets of next generations of large language models. And it's actually starting to get trained on the outputs of past predictions. This ends up watering down the whole system and making it less efficient. That sort of potent human created AI is powerful. We need to make sure to find ways to keep that really high quality human created training data separate, so that we can not, have the systems decay over time and just kind of get like dumber. Inside your own company, you'd be surprised that you need to do a bit of planning in order to make sure that the outcome and the output of a model isn't going to end up contaminating your training data for future models. So let's just take an example of like maybe medical notes. Let's say that you're having a generative AI system summarize notes. And let's say that in the past, the human practitioners were doing that notes summarization. Now, in the first generation of the model, it's being trained on fully human data. So you have like the most potent ability to teach it how to do the job. Then as time goes on, if you start to use your system in production, you'll start to have notes. Some of them are human generated, and this system will end up creating some of the notes also. If you don't plan to organize both sets of data, you will end up getting notes that were made by your AI system pulled into the training set of the model that is learning how to make notes. And if you don't take care of that, you may end up, having your system being trained mostly by things that produced itself. And then it'll just get worse and worse at the task. So, and that's never really a challenge that people are blocked with out of the gate, because most all of the data that you start with in a corporation or kind of in the world generally is mostly human created content. But as you start to use it and you use it more and more, you're really going to want to make sure to separate out and keep track of training material that is, really high quality versus the outputs of past generations of models.
Well, what we do know is that there's so much data being put into these models and are used to train and improve the AI models. And that's where data science, I think, comes in, and the crucial role that it's playing in able to really analyze these large data sets. So from what you've seen, what role does data science play, and how crucial really is it in the AI development and modeling?
That's a fantastic question. So we're in a space where a lot of the tools for making AI models and large language models are easily accessible. Many of them are open source. A lot of them are easily implemented in various cloud providers. So you can go pretty quickly from zero to having an AI system that predicts something. The purpose of data science, in my mind, goes back to the scientific method. It is the making sure that what you're doing is, call it statistically sound, that it's going to generalize well, that your model isn't overfit. These principles of machine learning and data science and sort of actual science are just as important today as they ever were, even in the era when it looks like you can just sort of go and take an out-of-box solution and apply it to your business problem. Because, the success or failure of a big project can really come down to details about how the model was trained, how it was back tested, where it's being deployed versus where it was trained, the sort of kind of data that it was trained on, if there's any biases injected into it. All of those sorts of fundamentals of machine learning that data science focuses on apply into the generative AI world, because a lot of those models are not just in their core training, but most of them in business cases are fine-tuned, which is taking a foundation model and then fine-tuning it in a supervised way with your own business data. And you don't want to come to the wrong conclusion if the technology is going to help you or not, because the experiment to demonstrate its usefulness was set up wrong, or you sampled your training data incorrectly, and so you have the wrong conclusions. I think it comes down to the kind of scientific and machine learning training of the data science community is an important backdrop to help guide organizations to using the tools in a way that gives them success. Because that, at the end of the day, they are just tools, right? But they're very powerful tools. And so it's the data science training background and methodology of training, releasing, and measuring the performance of models over time that's important to make sure that you're not surprised by them.
Yeah, I mean, Bob, you could even talk about the importance of modeling in general, and just how that makes such a difference, especially in this, covering a space like healthcare, when accuracy is important, and running on efficient automation and smarter decision making is pretty valuable. And in those real-time insights is almost necessary in a space like healthcare.
Yeah, yeah. Hallucinations it's kind of a big topic in AI and also in healthcare. It's probably one of the main reasons why it doesn't have faster adoption in healthcare is the risk of hallucinations, right? So there in a lot of business applications, there's two main kinds. There's mission critical, and let's just call it non-mission critical applications. Like if I get an incorrect recommendation for what song I might like, or what person I might know, or what recipe I might want to make, or a book I might want to read, those aren't mission critical. And so you can live with error in a kind of natural way. In healthcare, there's a fair amount of mission critical applications, which you can't inject data that wasn't there. You can't miss things that were there. And so the hallucinations are a concern in the generative world. What's really interesting about them is, they're just being, a hallucination is really just the model giving you the answer based on all of the patterns that it's seeing inside its training data. So it's a very human-made pattern, the decision about what the data is trained on. Like there's this really kind of funny, it was a blog story that I read a couple of months ago, but somebody was using one of the main AI vendors' tools, and it asked it to give it a link in a presentation. And later, when they ran through their presentation, when they clicked on the link, they found that it was that they got rickrolled. It was Rick Astley's "Never Gonna Give You Up." So you're familiar with rickrolling, right?
Yeah.
So people were wondering, well, like, why is it doing that? Is it playing a joke on me? Is it adversarial? Is it trying to like embarrass me when I'm trying to make a presentation? Because they were doing a very serious presentation. But then you think about why it might do that. And it's not, trying to do anything in particular. It's just following the data. On the internet, rickrolling is like a real joke, right? It's been going on for tons of years. You say, here's a link, but behind the scenes, you click on it and it's Rick Astley singing a song. And so what happens in the large language model, when it consumes billions of web pages with hundreds of thousands or millions of Rickroll jokes, it is inadvertently learning that Rick Astley's video is the answer to lots of different questions, because it doesn't know that it's necessarily a joke. It just sees that, oh, when somebody asks for this, you get Rick Astley. When somebody asks for that, you get Rick Astley.
Yeah,
So it is
pattern.
proudly giving you the answer of, oh, here's the thing you want, because because I see that that's the answer to almost everything. So it's just a kind of a funny example where the patterns that it learns it's learning exactly what we're telling it, but there's unintended and strange consequences to the actual internet. And those things usually manifest as hallucinations.
Never going to give you up. These, I feel like this is a good time to bring up my favorite part of the podcast, and it's kind of talking about the use cases and kind of the stories that are coming out of here. Interesting to find out some of your favorite AI use cases, Bob, and especially some of the things that you've seen at Veda Data and times when AI really outperformed other methods.
Exactly. Yeah. So, I'll connect it to something that I mentioned earlier where AI systems are held to a higher standard than a human doing the same task. And we want to improve healthcare as much as we can. So one application that we found to be extremely productive is in sort of the back offices of healthcare systems, both healthcare systems and healthcare payers. There's a lot of work that goes into trying to figure out simply what is all the right information for a provider. And the sort of status quo for how a lot of this information about providers is created is through a process called attestation, which is basically the physicians send what their answer is for who all their providers are and where they work. But it's a lot of providers to keep track of. And it is not always clear on which day, which provider works at which location. But AI is especially well suited to figuring out who works where, what their specialty, credential, license is, all of that core information that keeps the sort of healthcare system running. It's kind of like the oil inside the machine. And it happens not, not at the point of care. It happens more in the back office. So we're finding a lot of traction on automating and reducing the error rate and the amount of work it takes to keep just the basic data of the healthcare system running. It is less flashy than the applications of assisting physicians or physicians' notes or, assistance in diagnosis or MRI reading or anything like that. But it's really well suited to it because there's an enormous amount of data behind the scenes that has to be up to date on a daily basis in order to sort of keep the machine running. So we found that we can train supervised models in order to predict where all of the accurate information for physicians, so that we don't have to rely on in some cases making hundreds of thousands of phone calls in order to try to track the providers. There's enough signal that AI is able to triangulate their information without having to go through all of that work. So back office use cases, places where there's, call it, a lot of risk for error being injected into data sets, like when you transcribe data from one system to another. That's a great application for an AI system. When you have to classify things, that's a fantastic old school classic application for an AI system, which is because its core competency is pattern matching. So if you have a problem where you need to classify something into it's one of two things, or it's one of 25 categories. And that can be specialties. It could be if they're working here or not. It could be if you accept this insurance or not. Those applications where you need to take a problem and put it into one or more buckets is a great application in the healthcare system because it's less risky, because it's actually immune to hallucinations. Whenever you make a system pick one of two options, it doesn't have the ability to sort of give you a weird third option and surprise you. And so we're finding that we can make a lot of traction by casting problems in the back office as classification problems rather than generative AI problems. What's interesting is that the engine of large language models can power both types of systems.
So, Bob, I think in the introduction, I think I called you a tech guy, and that was a very much a compliment. And going going on this idea of technology terms in general, there's also some misconceptions of those who aren't perhaps tech people. They've been in the industry for a while, and they're overwhelmed by AI and the speed of which technology has transformed. And in terms of like common technology concepts, for example, like cloud. When I started doing this podcast, when somebody referred to the cloud, I think the iCloud, and I think of it as like a storage space somewhere up there. But speaking of the cloud and in data and in cybersecurity, it's a much broader term with lots of networking and software and databases. And so, curious about a common technology term that many non-tech people understand in your eyes, and what it actually means and why it's important.
Sure. So we talked previously a little bit about supervised and unsupervised learning. So I'll do a different one. Two terms that are related to each other, but often produce a fair amount of confusion is LLMs and Gen AI, actually. So and that's because they're often used interchangeably, but they're pretty different in that a large language model is really at its core a system that can represent words and phrases as vectors. The vector is kind of the way to represent things that a computer can understand. And they are trained on huge amounts of data. So the large language model means that you've got hundreds of millions or billions of parameters, which means you need just billions of documents of data in order to teach it. Well, what does this phrase look like in vector space? What does this word look like? What happens when I take this word and use it in this context? What does that look like in vector space? So the LLMs is really the way to understand the patterns in language. And you can use that in a few different ways. One of the ways you can use it is in a generative AI system, which is I'm going to give you a word or a phrase or a document, and I want you to find the most likely next word or phrase or document. And it creates something, creates it, it looks like it kind of comes out of thin air, but it's coming from all of the patterns that it's learned in its training. Other things that you can do with large language models are have it classify things into buckets. You can have it use all of its learned patterns from the language in order to put a text document into one or more categories. You can have it predict a number, like what kind of rating would this book get? All of these, those are applications of LLMs that are not generative. See, so the generative piece means that you're making new text from scratch. You can also ask an LLM to put things into categories, put them into buckets, predict yes or no, or predict a numeric value. Those are, you would call those more of a generative is the one application, discriminative is the other, which really is just saying you're putting things into buckets. And so the ability to use LLMs in both ways, I think, is overlooked a little bit because the generative piece is kind of so impressive and new that it gets a lot of the attention. Chatting with an LLM is really kind of a unique and interesting experience. But the benefits of having the LLM trained on an enormous corpus of data can also help supercharge systems that aren't generative. And so just the difference between the LLM and the generative AI part is definitely I see it adds a lot of confusion into the industry.
Yeah, even as AI and ML. So, Bob, I want to be cognizant of your time, and I only have a couple more questions for you for the podcast, and this has been a great chat already. But more so looking ahead, what do you see as the most significant trends or challenges in healthcare data? I know there's a lot of challenges in healthcare, the entire industry, and what it's going through now. But how is Veda positioned to address these challenges and with AI?
Fantastic question. I think, yeah, the biggest challenge in my mind is using AI in the right way so that we get benefit from it in healthcare. And I say that because every time an AI system makes a gaffe or a funny result that's incorrect or a hallucination, those tend to be headline news or at least make their way around the internet. We can't have that same kind of thing happen inside healthcare, or it may influence opinions and regulation that will really slow down its ability to benefit the American healthcare system. So making sure to deploy it in ways that are going to be safe for members while improving their healthcare experience is important. So Veda is approaching that problem by attacking expensive error prone and inefficient processes that help make the system run. And but I see that's the biggest opportunity and the biggest risk in my mind, which is making sure to use it in places where you know that it's going to succeed, right? You don't want to have it put in a position where it can produce harm, and that harm will end up slowing down the development for the whole industry in that sector. And as I said before, it's up to the human practitioners of these AI systems who are responsible for putting it in the right environment to succeed.
Yeah, I mean, AI is going to be like a pretty necessary tool to have to solve healthcare data challenges. And just curious, Bob, of what you think, and as a leader in the industry, and all the great work that Veda is doing to really help solve and tackle these challenges. What does the healthcare industry really get out of it in the end, and perhaps what does it look like in the future if the success of AI continues on this path?
100%. In my mind, it will be a successful outcome if we can realize the future of physicians spending more time getting to know and taking care of their patients. I know that the physicians definitely feel burdened already with the amount of, call it, administrative data processing and tools, digital tools usage that they're obligated to do. We don't want to make systems that demand more of their time, right? It's our responsibility to empower physicians with tools that will allow them to spend more time doctoring, right? With the patients, having conversations. We know that, when patient and doctor relationships are better, there's better outcomes. When there's better communication, when there's a concordance, in matching the right, the relationship is important. And one of the biggest risks of adding more digital tools into the doctor's office is that the doctor is then interacting with the computer more and in with the patient less. And it's our responsibility to make sure that the applications that we allow and that we push forward are ones that keep that fundamental piece in place, which is let the doctors take care of the patients and let's empower them. It could be with AI tools to help them look at more data in a more summarized way faster. It could be to take care of referral paperwork that might happen behind the scenes that they would have to do. But we need to make sure that the end goal here is to get them more face time with their patients and less time just doing other things.
Yeah, the end goal should always be to improve patient outcomes. Dr. Bob Lindner, thank you so much. This has been such a fantastic chat. Thank you for taking the time to just really talk about the thrilling advancements in AI, specifically in healthcare and healthcare data. And thank you for exploring the differences between supervised and unsupervised learning. I think that really is a valuable lesson, and how organizations can really know when integrating AI into their operations is right for them. I think that's really going to make a positive future and, again, produce better outcomes. So, Bob, thank you so much again for taking the time and what Veda is bringing to the industry. We really appreciate you as a partner and for really what you're doing in healthcare.
Yeah, Connor, thanks so much for the invitation to come speak on the show. Super grateful, and I had a fantastic time.